We use a wash bottle to wash. Use DI water to wash directly through the hole. But now I just do a quick process. And after we replace the this is just now the training particles. We just take it one. And it will ask us to put it into the fresh running buffer, because we need to check there is no particles in it. If there's no if there is particle in it, it will affect your sample reading. So which means your sample contains the previous calibration particle.
Yeah.
Here you see there's no particles, which means the clean just now is very sufficient. Because I accidentally unplugged the pressure nozzle, it's returned to error. But now you see here. Basically, this interface, you can see there are some particles, just one particle, but it's not it will not take a big deal because it's running at a very high speed. Usually, at very high speed, it's less than like 20 particles. It's fine. And the system is running all guided mode. So you see here is tell you every step you need to do. So but this step is guided mode is very good for new learners. So you don't need to worry. So you don't need a teacher. So just watch it, or it tell you everything you need to do. So here you can see it tell you the washing step has failed. So in that case, in that step, you just take the flow cell out. Use why it's failed, because like usually we will use a wash bottle to wash the flow cell insert the nozzle in it and wash it directly. Okay. But this is insufficient wash, so it still contains some particles. But we do it twice, so should be no problem. We wash it twice, so yeah. And put it back in the shading tape. Yeah. So we assume it's cleaned now. And now if the nanopore is cleaned, we ensure that one. And then we do in the sample S. Sample S. The dilution is also, we did just now, it's 51 times dilution. Click down. And please replace the electrolyte we just put it in with the training sample. We just remove this one and then remove this one. Put it back. And then this one is the sample S. We put it into the sample S. Directly to the bottom. And the shading cape. Put it back. And then follow the guide or insert the pressure nozzle already. Close the lid. And choosing you can see here, can choose what's the number of particle you want to collect. Usually we choose 250 or 500. For this one, because for this two is already got a significance. So currently we just choose for example 500 and click done. Because the system recognizes your calibration. We do first, and then it will do the samples under the same parameter as the calibration particles. So it's still 3 pressure. You see the pressure, voltage, stretch is the same. So we just need to wait for it running. Yeah. So basically, you have if you have other things to do, so just for example read a paper and then just. Currently, because the nanopore is running for the first several use of the nanopore, so the nanopore is quite clean. It doesn't have any, for example, a non-specific protein bonding to it, so it's running quite smoothly. When the nanopore reaching is a lifetime, which means around 5 hours use. And if you run too many biological samples, we know that the protein will have non-specific bonding to because the nanopore is plastic. Yeah. Even though if we coated it, so. Which means the nanopores may easily to block, which means just
how many times the nanopore? How many types of nanopore? They are different in diameter. Only one type diameter.
You mean how many times you can use the?
Yeah. That means in your company, how many types of nanopore?
Sorry.
That's
How many?
mean
Thai
the
of
diameter.
Size.
Yeah.
They are around the six. For example, 6 type. MP 100, MP 150, MP 200, MP 400, 800. But because we produce so many type of nanopore, it fit different use. For exome use, we just use MP maybe 100, 150, and 200. Depends on what's the lower limit you want. If you want the lowest one, maybe use the MP 100. But MP 100 is slightly difficult to use because it can go down to very small size.
Yeah.
Usually we use MP 200. It can cover from 50 to around 300 nanometers.
Can I check the information?
Yeah. So cannot.
Based on this number?
Based on this number.
This number.
This is the median measuring range.
Yeah.
So this one is the best. Usually we know that the exome, the average diameter may be around, I think is around maybe 100. So usually use to say like MP 100, MP 150 to analyze it. So this one is the series number. So it's used for our QC purpose. There's no information here, so it's just for our record. This one is just when customer report or receive very dirty nanopores, we'll check our production data and say, this problem just replace it.
That means in your system, can we use 6 different types of the nanopore? 6 types.
6 types.
Yeah.
Yeah, there are lots of types. We can there's a draw down menu. You can select what's the nanopore match this, because when you load the nanopore, you need to input this series number.
Yeah.
So it's for our QC purpose.
If that means I would like to know this numbers 1, 5, 0. That means
so it's the measuring. It's used for measuring particles with mean around 150s, which means the lower side maybe around the 760 to 60 nanometer. So it's the median mean size.
Okay. But this is suitable for exosome.
Yeah.
But if I use it for EV, maybe more than about 500. Can you?
You should use MP 200. I think there's MP 200 here.
No.
Okay. We provide all the nanopores.
Yeah.
So as you see here, the sample also finished. Also got QC reading here. So it means it's linear, which means the measurement is successful. We just click done, and then after each sample, it will ask you to replace it with electrolyte. Usually we use water to wash it, and wipe down it, and to put back it. Click OK. So it will wash the nanopore by itself. So basically just one sample finish, and after it washed, and then it report like washed successfully, you can continue the second sample, the third sample. It's just this procedure. First do the calibration, and then wash the nanopore, load the first sample, finish the measurement, clean the sample, clean the nanopore, load the second sample, and continue.
Yeah.
So you see the nanopore is quite clean. See the report clean.
Okay.
Because I just done that way. So usually you need to wash that one, and then it will ask you whether you want another calibration or just run another sample. I don't want, so just run another measurement once more.
Okay.
So basically you can see the speed is quite fast.
Yeah.
So
calibrate will be done every time I use any EV or exosome.
usually we need to suggest the calibrator every 3 to 4 samples.
Okay.
Yeah.
After 3-4
You do another
Is
calibration.
it continuous or day after day we can?
After 3 to 4 samples, you see that it asks you, do you need another calibration? You click the yes.
Okay.
We need to do another calibration and run the other samples.
Yeah.
Because previously I said that the nanopore has a lifetime. That means because of this made of plastic, so the nanohole in it is tend to become larger and larger. So, but it's not saying that it's not useful. So because previously we said it's tunable, so the structure is actually tunable. So to maintain the whole size,
Yeah.
we just reduce the structure. The structure starts from 47 and it can reduce to 43.5. So you have like a 2.5 milliliters range to reduce the nanopore whole size to maintain its accuracy. When you reduce the whole size, when you need to reduce the whole size, that means like when you do a calibration, new calibration, you found that the calibration mean size cannot maintain like a 0.2 nanoamps.
Yeah.
Previously, you see this histogram showing the mean size. If it cannot maintain 0.2 nanoamps, which means because it's linear, so it cannot detect the lower side of the around 50 nanometers. That's why, for example, it get large. The mean size is only around 0.1. Then you reduce the structure to 46.5. So because like we reduce the structure, so the whole size get smaller.
Yeah.
And then the same particles, the blockage will be larger now to return to the 0.2. So that's the place we need to do another calibrations also.
But this is you only to calibrate in the software, so we can change.
We need to every time we need to use the actual calibration particles.
Yeah.
Because like it will record a new set of data under that condition, under these conditions. So for after 3 or 4 samples, we reduce the calibration and continue that one. The speed, if we experience the user, so when we analyze like a plasma UV sample, purified plasma UV samples, usually we can have one afternoon, we can do around 20 to 30 samples, because the plasma UV is quite a high concentration and then easy to run after purified by the QUVs. And so, for example, now I have finished the measurements. For example, I've done a lot. We just finished the reading. You can see just for the nanopores can be stored and reused for next time. Yeah. For example, this is the end of today. The system will ask you to fill in the lower flow cell, upper flow cell with DI water.
Yeah.
This is to be remove the salt.
Yeah.
And then after